Okay, now we move down to problem 16 on the document, and that concerns the set of letters A through H, 8 letters, and we're going to select 3 of the letters. Okay, now the way the questions are phrased, we want to select 3 in order first. There are 8 choices for the first letter chosen, 7 for the second, 6 for the third. So by the fundamental counting principle, there are 8 times 7 times 6 ordered possibilities. Now, D, G, H is one possible ordered choice of 3 members. Okay, D, then G, then H. Questions, what's another possible order? Well, everybody can answer that pretty easily. D, H, G would be another ordered choice of the same 3 letters. Now you could list all the orders, and you would find that you get a list of 6 if you do this carefully. But you can also reason out the fact that there are 6 possible orders for D, G, and H, because there are 3 letters there. You have 3 choices for the first of the 3. Having chosen that, you have 2 choices for the second and 1 choice for the third. And that gives you 3 times 2 times 1, or 6 possibilities by the fundamental counting principle. So we say there are 6 ways to order these letters. Now don't pay any attention to this 8 factorial over 3 factorial times 8 minus 3 factorial. That goes with this, and we come down here, and then I had to go to the left. You understand how that can happen. Okay, so now the point is, the reasoning here, and this is reasoning that people still find a little confusing, and you're going to be much better off if you understand this reasoning as clearly as possible. Okay, you might be able to get by without understanding it, but you're going to get by with a lot more certainty, and you're probably going to do better if you do. So, the set DGH is an unordered choice. Okay, sets are unordered. Now, for that set, we've seen there are 6 possible orders of these 3 letters. Okay, well, that means there are 6 ordered choices for each unordered choice, because the set DGH is an unordered choice. So we have an unordered choice here. I'm trying to get my sleeve out of the way so it doesn't flap and block the board. Okay, so again, here's an unordered choice. This unordered choice is equivalent to the set G, D, H, or any other order, because the order in which you list members of a set doesn't matter. However, if you take the members out of this set and put them in different orders, there are 6 possible ways to do it. Well, this means that there are 6 ordered choices for each unordered choice. If there are 6 ordered choices for each unordered choice, what's there more of? Are there more ordered choices or more unordered choices? Think about that and see if you can get that in your head before you read. Okay, well, there are more ordered choices than unordered choices because there are 6 times as many. For every unordered choice, there are 6 ordered choices. Okay, now, if there are 8 times 7 times 6 ordered choices, then how many unordered choices are there? You should try to answer that before you look at the answer, because people answered this wrong. Okay, it's confusing. I have to stop and think for a minute when I think through these questions. Even though I've been through them about 1,000 times, I still have to stop and think. It's not that trivial. Well, okay, now let's go ahead and answer the question. Okay, there are this many ordered choices. There are more ordered choices than unordered. So, and there are 6 times as many ordered choices as there are unordered. So, if we're going to have to divide the number of ordered choices by the number of ordered choices there are for every unordered choice. So, and we're going to get a smaller number, as we've seen here. They're more ordered than unordered. If we know how many ordered, we're going to have to divide by 6 to get the number of unordered choices. So the number of unordered choices is equal to the number of ordered choices divided by 6. And that comes out 8 times 7 times 6 divided by 6. Of course, that just comes out 8 times 7, 56. We could also write the 8 times 7 times 6 over 6 as 8 factorial over 3 factorial times 8 minus 3 factorial, which is just trying to figure out how to write an 8 here, which is 8C3. because again, we're choosing 3 out of 8 unordered choices. Now this should help clarify the formula, the concept of combinations, and the relationship between permutations and combinations in a way that I hope will be helpful to you.